Here we're asked to find the inverse of this function first. So switch this to y, switch x and y, and then solve for y. So I add 2 to both sides. I got x plus 2 equals y cubed. Then I take the cube root of both sides, which gives me my inverse. So inverse of f of x equals the cube root of x plus 2. Then now it says to graph the original function and its inverse. So original function is a cubic function, which, I know it's kind of that shape there. And the only transformation from the parent function is that it goes down 2 units. So from 0, 0, I'm going to go down 2 units. That's my turning point. It doesn't stretch or anything. So it's going to be going through those 2 points. And there is my sketch of the original function. Now the inverse, remember, just takes all those x and y values and flips them, right? So if this coordinate right here in the center is 0, -2, then I am going to have a point at -2, 0. So right here, I have a point at, 1, -1 here. Then I'm going to have a point at -1, 1. And if I have a point at, -1, -3, then I'm going to have a point at -3, -1. So in this one here, we have it's going from left to right, because if I continued, for example, and we had a point, let's say 1, 2, and then we go up to here on this graph here, right? This is 2, 6. If I were to switch that would be 6, 2 in purple here. So we really like to make sure that we know the general shape. Maybe try plugging in one more point, but we got to know that the inverse of these cubic functions is more of like an S shape. We don't want to get confused and think like, oh, it has the same shape as the cubic function. So just be careful on that. Our inverse has to be kind of pointing left to right.